All right, so David Goldschmidt said I could come talk to you guys pitching projects. So I'm going to tell you a little bit about a project that we're starting small this semester and hopefully growing rather large in following semesters. And so IBEIS is the big project and HotSpotter is John Qual's thesis work, and so we'll just give you an overview. So IBEIS stands for Image-Based Ecological Information System. And you guys like to take pictures, right? Anybody ever been on a safari? How many pictures did you take? A lot. Yeah. So people take thousands of pictures. And they stand up in the tour buses, and if they're lucky, like idiots like me, I was actually allowed out and photograph these rhinos a couple weeks ago in Kenya. There are also UAVs and camera traps, which are cameras that are sitting in key spots, and they click on, they have infrared sensors, they click on, take a bunch of pictures, and click off. And you get pictures like this. So the point is, you could get, if you're at a conservancy, safari park, anywhere, and you asked to collect all the images that were taken there. And we did an experiment where the research facility where there were 21 Cornell undergrads, and 17 of them contributed their camera chips to take pictures. So if you can get 10 to 100,000 images a day, can you make any sense of this? And if you've taken pictures, these are like 9 consecutive pictures I took, and I couldn't make sense of them. But can you write software that does? That's the key question. Okay, and if you can do that, what happens is you are providing answers to the questions: when are the animals active, as long as you've changed to the local time zone in your sensor? Where they're active, if you or somebody else at least on your group has a GPS in your camera. And who the animals are, and who might mean species, or in our case, for a large number of animals, individuals. So one of the first experiments I did with the data set is I pulled up the pictures of one of these zebras, ran it through John's software, and it matched from a picture 2 or 3 years ago. And now I thought that was pretty cool. But then ecologists and conservationists can use this to answer fundamental questions. What are the animals doing and why are they doing it? So for example, there's they were stumped by the fact that the elephants in this research park were knocking over all the acacia trees and trying to figure out what was really happening and why it was happening. Other interesting things are trying to figure out how animals are using the land. They're trying to figure out the relationship between camels, which are their dairy, at least in the High Plains region of Kenya, which are the dairy animals, and how they use the land versus how the giraffes and the zebras and the elephants are using the land. You also might want to know where your endangered or poachable species are in a large park, so that you can allocate your resources for protecting these animals and know where they are, where the poachers might not. And we actually got to see just randomly training of a poaching attack dog. It was rather scary. So we came up with this IBEIS architecture. And the way this architecture is going to work is we have a large amount of data input. And as I said, it comes from field scientists, it can come from camera traps and sensors, UAV, video tracking, and lots of citizen science crowdsourcing. And it's really 10 to 100,000 images a day. We have a citizen science interface, this is part of the plan, where people will contribute images and then be kind of gradually invited in to become more informed and more participatory after their visit. And people are starting to do social networks or have web pages for individual animals. And so, for example, if you contributed a picture of a giraffe, imagine just saying, okay, here's my pictures, and it comes back and says, here's this giraffe, here's its life history, here's its association, here's its parents. It might kind of freak you out, but you get a little more invested, especially if you go home and now you will get daily or weekly updates, or really daily or even hourly updates on the giraffe and the environment. So part of it is this citizen science interface where people can contribute images and become more engaged in what's going on. The core of what my PhD students are doing is this image analysis, which is automatically detect animals, label the species, and identify individuals. It goes into an image database, an image management system, or an information management system which stores the who, what, where, when, or who, where, when. And then there will be times when the software does not work, and we will require a citizen science interface. And then what comes out is the scientific analysis. This is the goal anyway. So the citizen science interface, if you look at this, has anybody played with Smithsonian Wild or Project Noah? Anybody play with any of these? Okay, so Instant Wild, there's a lot of software systems where you can take pictures with your cell phone and you upload them, and someone may be able to identify the animal, tell you what species, it's a little bit of life history. So it's a bit of a community science effort. But this interface is like one picture at a time. We're talking thousands at a time, so a huge difference. But anyway, the leader of Project Noah, which is, and it gets back to what Colin was talking about. The leader is Project Noah is a for-profit closed source company. And in fact, they're partially owned by National Geographic. And how many people knew National Geographic was a for-profit company? I did not. Anyway, the leader of this is going to join our project. The goal is to have him come up here and work with us to design this interface. We will implement it. It will be open source, but then they may take this is again just ideas and proposals. They may then take this, close it, and put generations on top of it that are closed, which then requires an Apache style license. So Project Noah would be the citizen science interface. There's a number of image management, information management systems. We're going to work with the team from Wildbook. It started in a lot of large ocean animal projects, so the whale sharks. They're doing humpbacks, right whales, manta rays. We are going to, once we build the image analysis software and the back-end environmental or ecological query management system, we're going to install this in 2 places in Kenya. The first one's in Pala Research Center. The second one is Olpejeta, and it's a non-profit conservancy. They're hosting the last 5 northern white rhinos in the world. 2 of them were looking to trample me. So this is a 45,000 acre facility, but it's open around it so animals can move among the different ranches. So we're going to install it there and do both scientific experiments and conservation experiments. So this is what we call our wall of fame. And there's a variety of species that the HotSpotter software can handle right now. So HotSpotter basically, it has a database of pictures of animals. You give it a new animal and it will tell you who it is, or at least give you the rankings of the top 5 best matches. So it's worked successfully at various levels of experimentation on leopards, elephants, various types of frogs, Grevy zebras, jaguars, lionfish, plain zebras, rhinos, although that was the reason I was taking pictures of the rhinos. Some question about how well it really will work. Seals, what are these, John?
Those are snow leopards.
Snow leopards.
Those are hard.
Those are hard. Whale sharks, wild dogs, wildebeests, nautilus, no idea, and giraffes. So John, do you want to take over and give a quick demo?
That one's Wyoming toads.
I knew that. Okay, so John's going to quick demo, and then I'm going to wrap it up, okay?
So all the software is written in Python. And it's written efficiently in Python too, believe it or not.
Well, it's calling OpenCV C++.
This is on Windows, but I assure you that I do have a fully functional GNU toolchain on here. I can't get it on my... Okay, so I guess I'll just try and run it like this. So here is the main GUI. We have a bunch of images. Here's one image. You can add images. You can add ROIs to these images. Where I'm going to select this one in particular, and I'm going to ask HotSpotter to find the six closest looking animals to it, and it's going to pop back this result. So here's the first two matches, which are the only two correct matches in the database, and then the scores kind of drop off after when you get into these wrong animals.
So how many images in the database?
This one's 119, but I can switch to one that has like about 1,000. So this one's a different species. Those are plain zebras, and these are grevy zebras. So let me pick one that has a couple views of it. So this guy. So here's the three views of this animal in the database. Let's pick this one. I don't know if it's going to work.
So we're talking about the same animal now.
This is the same individual animal. This is spreading zebra. So I'm querying him right now. This interface is not written, is written for me more than anyone else. So it's going ahead and it's loading all those features.
So it's loading its cache right now?
Yeah, well, yes, well, it's loading the cache features. It's a little bit more time than that. Now it's actually doing the computation. It's not, this is doing spatial verification. No, so it found both of them. There they are. And what's another cool thing that I can do is I can memory respond.
So that's why we're here, memory.
Yeah, but here we go. So I can actually take one image of a zebra and superimpose it on the top of another image of the zebra, and that's how we do verification that these matching points are actually matching the same, the spatial consistency, the spatial verification test. There's do one more species. These are my, I like these ones because they're small and they're cool. Yeah. So here's Nautilus. Let's select him. And let's see if any other Nautiluses have been seen like him in the database. And there he is. Let's click him to get a closer view.
What's a nautilus?
A nautilus is, it's a shellfish.
How's that not? Okay.
It's very old species. Where'd he go? All right, yeah, that's pretty much it.
So I got a couple more slides. All right, so the computer vision, we talked about the citizen science interface for image upload. There's the image management and database system, which is we're partnering with a group from Wildbook to build a new generation of their software. The core algorithms that my research team is working on is detect animals, determine species, do the individual identification, and then to try to make a sense out of the mess of pictures is to use this to organize all the pictures locally in space and time. And so here's an example of pictures we took a couple weeks ago in Kenya, where we had this particular animal, and then we had this series of images, and it matched across all 6 images. And so you begin to start to build like a graph of connections among the animals. And that's kind of the key to getting this algorithm to help organize the mess. So what are we after? We just submitted last week a $2 million NSF proposal, and we're going to go after some foundation money. So here's what I did. I promised some of your help. We have 3 graduate students. There's funding for at least 4 undergraduates. And we're going after, if we get this, we'll go after more. All right? And so this is a serious project. So the undergraduates are going to do, at the very least, some of the user interface, some of the citizen science kind of information presentation, a lot of the back-end database, graphical databases, and some system issues, and then some of the science part. The rest of the team includes people from Princeton, University of Illinois Chicago, University College London, Project NOAA, WildMe, and Microsoft Research Cambridge UK. And I'm going there in April and trying to get some of the Connect crew to join and contribute some of their algorithms. What do we want this semester? Well, John is going to be doing generation 2 of HotSpotter. And what we need, he's done all this himself, and very often PhD research software is not exactly the highest quality. John's software is very good, but I don't want him spending all his time on user interface and other things. So we need a good user interface design, and design for the point of view of the ecologists and the technicians. We need to deal with speed issues, we need some test harness, and we need distribution utilities and tutorials, because people want to use this on Mac, Linux, and Windows, and it mostly works, but we'd like to really have it work really well. So what I'm really looking for is a group of a few students to join us and see what we can do, and then if we get lucky to get funding, it might grow to 6 or 8 student team next year. And you've got 3 minutes, sorry. Are there any questions?
Are trips to Kenya included?
Yeah, so, yeah, no, I was waiting for that. So I went for the first time just after New Year's, just after New Year's in the blizzard in Boston. We were the last flight out. It was pretty scary, but it was kind of cool. And the core ideas that we put in the proposal, none of them, they all came out in Kenya. Then there was and some of them were at like 1 in the morning after a couple bottles of scotch, but we won't talk about that. And you really just have to be there to get it. And so the plan is actually to take, if we get the funding, what I put in there was a team meeting in Kenya after finals week in December. So I can't promise that we're going to succeed. In fact, our chances are less than 50%. I think our chances of funding this long term are very high. So I'm not sure when it'll get going. Anything else?